together with my teammates Fabian Schley, Rakif Matzkul and Shona Drexel, we worked on this project. In our presentation, we will show you how we improved an AI cobot using a new camera system and artificial intelligence. We will also explain where this technology can be used in the future. Now let's take a closer look at our project. Our main goal was to enable the robot to pick up objects on its own, using pattern and color recognition. This system also includes self-learning features, which allow the robot to improve over time and work more flexibly. We are already working together with Odessa National Polytechnic University on developing AI applications, using a cobot provided for this purpose. On this slide, you can see an example of the collaboration between the Technical University of Applied Sciences Augsburg and OMPRU, supervised by Professor Ewald Roos. As a part of a bachelor thesis, 2 industrial robots, KUKA 30, are being prepared for uses in teaching and research at OMPRU. Here, on this slide, you can see some technical details of our project. We installed a new camera system, connected it to the robot, and linked it with an AI system. At the same time, we found some limits of the existing setup, such as old hardware and missing modern interfaces. These results helped us to improve the system and define the next steps for future use in education. One big advantage of cobots is how easy they are to program. Unlike traditional industrial robots, cobots can often be programmed by simply moving the robot arm by hand to the desired position. This position is then saved. This method is called teach-in process. Makes programming much faster and easier, especially for beginners. This is very helpful in education, as students can get started without needing advanced programming skills. But also, another important advantage of cobots is their ability to detect collisions. They use built-in force and torque sensors to notice contact. If something unexpected happens, the robot reacts immediately, for example by stopping. This is very different from traditional robots, which usually work in closed-off areas. In learning environments, this makes working with robots much safer and more flexible. Here on this slide, you can see our camera system in action. On the left-hand side, you can see the robot moving, and on the right-hand side, you can see the image analysis by the AI. The robot picks up an object, takes a picture, and the artificial intelligence recognizes its shape. Then it looks at the work surface and finds the matching position. Finally, the robot moves there and uses a pressure sensor to make sure the object is in the correct space, as you can see in the video on the left-hand side. This slide shows our SWOT analysis of the AI cobot project. The strengths are the hands-on training with real industrial robots and the use of modern cobot technology. But there are also weaknesses, for example, the old hardware and limited features compared to the new system. On the other hand side, there are also some opportunities, the great potential in education, especially for lab work, research and AI applications, and some threats. The possible technical problems, maintenance effort, and limited availability of spare parts. To finish, we want to show how this robot could help the Ukraine in the current situation. It could be used in construction, for example, to sort materials from debris. It could also help in agriculture, such as sorting crops or supporting planting. In addition, thanks to its safe interaction with humans, it could be used in healthcare to support patients and staff. Sorry. No, last slide. We hope that you were able to recognize the potential of the AI cobot system as well, and if this QR code leads to the website of the TRR if you are interested in other projects of the Technical University of Applied Sciences Augsburg. And if you have any questions to the topic, feel free to contact our project supervisor, Eberhard Roos. And on behalf of the Team AI cohorts, I would like to thank you for the opportunity to have been part of this year's hackathon. Thank you very much.
Thank you very much. I would like to say thank you, many thanks for Professor Ross and your team for support our mutual collaboration, and especially our mutual Ukrainian-German artificial intelligence and robotic laboratory. Thanks. And another question from our jury.
Thank you very much for being part of the hackathon.
First of all, appreciate your presentation. Thanks a lot. I'm not so professional in this area. I saw your presentation from your university last year, and one question from my side: what is the progress for this year? Because for me, it was a little bit the same, very similar. Yes, thanks. Shortly, can you explain us? Thanks.
Yeah, of course. The process from last year to this year is that now the robot is able to, with the picture analysis, to look at the shape of the bottom part of the cubes. So now it can detect, I go back to the photos. You can see it here on the right hand side. The robot makes pictures of the bottom part of the cubes, and then he also makes pictures of the processing fleet and looks where exactly this shape is. And now he sees, like, there's a triangle, and then he looks which triangle is the nearest to the triangle he has the bottom part of the cube is. And then he goes there and places it there, so it's more flexible. Did you understand the process?
Thank you very much. Appreciate it. Guys, we can work with next forward.